5.5 Negative Exponents and Scientific Notation. We're definitely making a little jump from 5.1 to 5.5, but 5.5 deals with some more information about exponents, so seems like a good time to do it when that's fresh on our mind from 5.1. What we need to know next is how to deal with an exponent when it's negative. Negative exponents can come from something like x to the third over x to the fifth. We know x to the third means 3 x's are being multiplied together, and x to the fifth means 5 x's are being multiplied together. Since multiplying and dividing are opposites, we have a lot of cancellation. Every time x divided by x cancels, it leaves a 1 behind. So pretty much everything on top of the fraction cancels, leaving just a 1. And then down below, we still have a couple of x's left over, 1 over x squared. Also, we know from our quotient rule, since these bases match, we can keep the base and subtract the exponents. 3 minus 5 makes a negative 2. So a negative exponent results. And what we need to notice is because those extra x's are left on the bottom, a negative exponent really results in a fraction. Let's put that in a line here. A negative exponent makes a fraction. Notice the fraction's not negative. Only the exponent was negative, meaning there are more x's in the bottom than on the top, so a fraction results. Could you use that same idea to write the other half of the rule or formula for how to deal with negative exponents? Notice on that fraction we're going to have a 1 on the top, and then the same base that we started with on the bottom, now though the exponent is positive. In other words, a to the negative n would be rewritten as 1 over a to the positive n. Try using that same rule to fill in the 3 examples down below. Might be a good time to pause the video and see if you get the same answers we have in the notes here in a minute. So y to the negative fourth would equal 1 over y to the fourth. 5 to the negative third, we might be able to do a little bit more with because now there are no variables. We have all the numbers filled in. So for starters, I'll make it 1 over 5 to the positive third. And then we know that 5 to the third power is 125. So that equals 1 over 125 eventually. When the base is in parentheses like this one here, it's a good idea to leave it in parentheses to make sure the sign works out correctly. So let's start by making it 1 over negative 6 squared. And then we know that negative 6 times negative 6 makes a positive 36. So that would equal 1 over 36. What we want to think about next is what would happen if the problem already had a fraction in it? Kind of like we see here, 1 over y to the negative third. Well, if you think about what we saw before, if the y to the negative third was on top, it basically got shifted down to the bottom of the fraction. And what we'll see here is just the reverse. If that negative exponent is in the bottom of the fraction, it would get shifted up to the top. So let's move that y to the top. Let's make the negative exponent a positive. And we'll see that it's not a fraction anymore. By shifting that up to the top, it becomes just y to the third. So we could maybe combine those ideas and say, okay, if this x is raised to the negative second power, I would shift it to the bottom and make the exponent positive. Whereas this y is raised to a negative power as well, so let's shift it to the top and make its exponent positive. So moving any base with a negative exponent up or down to the opposite place of where it started will make the exponent positive. And that's usually something we want to do. You'll notice in a lot of the instructions for this section and from now on, we want to leave our answers with only positive exponents. So anytime there's a negative, we want to shift that up or down and make it a positive. What would that look like as a rule if we had 1 over a to the negative n See if you can fill in the other half. So let's shift that a to the top, make it a positive n, and since it's just over 1, we don't need any fraction anymore. That would just equal a to the n. So try pausing the video, seeing what answers you can come up with for the 7 problems down below, and then tune back in and see if we get the same thing. For number 1, we're looking for 1 over z to the 7th, just using our basic definition of negative exponents. For number 2, we're going to use our definition, and then because there are no variables, we can keep going. Simplify that all the way to 1 over 81. Number 3 is kind of similar. Let's start with the definition, and then let's raise that negative 2 to the 6th power to get 1 over 64. Number 4 is an example where we already had a fraction, so we'll just shift that y up to the top, make the exponent positive to get y to the 7th. Number 5 is already a fraction, so any base with a negative exponent needs to get shifted up or down so that we can make the exponent positive. The q ends up on top, q squared, over, the p ends up on the bottom, q squared over p to the 3rd. Number 6, the exponent negative 7 here is only attached to the x. We can tell that because there are no parentheses around it, unlike number 3, where this negative was in the parentheses with the 2, so they stayed together. In this case, it's like a coefficient of negative 1, one of those invisible negative ones out in front. So only the x gets shifted to the bottom. The negative will just stay out front, and that's going to equal negative 1 over x to the 7th. Number 7, the bases this time are the same. We have a y and another y, so we're able to use our quotient rule. Sometimes people like to go ahead and shift everything around to make the exponents positive, like move that y to the 9th up to the top. And then you could subtract 9 minus 6. Or you can just subtract them right as they are. Start with the negative 6 since it's on top, minus the negative 9 on the bottom. Double negative makes that a plus. Negative 6 plus 9. We end up with y to the 3rd. Now that we've seen all the different rules for exponents, we want to know how to use them together. This will help us simplify any expression involving exponents, especially when there are bases that are the same. Just to peek ahead, like this one here, all of the bases are x's, so that one should simplify a whole lot. We still want to follow PEMDAS, the order of operations. When it comes to parentheses and extra exponents, that means the power rule. So anything like a to the n to the m is where we want to start. First step is to use the power rule. Get rid of those parentheses, multiply the exponents. Multiplying is when we want to use the product rule. So what we want to look for second, number 2, is any bases that are alike and being multiplied together, like a to the n times a to the m. We saw in our last section that is, let's see, we'll keep the base and we'll add the exponents. That equals a to the n plus m. As far as dividing goes, that's when our quotient rule applies. So what we want to look for third, number 3, is anything like a to the n over a to the m. Quotient rule, so keep the base and subtract the exponents. We won't be able to add or subtract bases that have different exponents. So really the only other thing to consider, number 4, is don't leave any exponents that are negative. No negative exponents. So we want to use our rules in this order. Power rule first to get rid of parentheses, product rule, quotient rule, and then make sure there's no negative exponents left. The problem below here is a good example where we have lots of x's raised to different exponents. Should simplify a whole lot. For starters, let's see if there are any parentheses and exponents that could be multiplied, like the x to the 5th cubed here. Let's start with the power rule. So x to the 5th cubed, we want to keep the base. We want to multiply the exponents. And then as we drop that down, let's keep the parts we haven't done yet. We've not done the x squared yet, so let's write that down. And we haven't done the x to the 7th yet. Power rule first to get rid of the parentheses. Now let's look for product rule. Any bases that are alike that are being multiplied together, like we have on the top here. We know the product rule says keep the base and add the exponents. So keep the x, and 2 plus 15 makes 17. I have not done anything with the x to the 7th yet, so let's keep that in the denominator, drop that down. And now let's look for quotients. Any like bases being divided where we could subtract the exponents, like we have right here. So keep the x, subtract the 17 and the 7 to get x to the 10th. Since the 10 turned out positive, we don't have to worry about any additional steps. We just see that that whole mess there, that big expression, simplifies all the way down to x to the 10th.